Okay, before we get too detailed in this regard, I want to make sure people understand what this word, these words, end behaviors means, what we're talking about. Okay, now we're getting into graphs of polynomials, which make all kinds of crazy looking shapes. Okay, you might have something like this right there. Okay. Now, most people, when they see that, they're drawn immediately to these little ups and downs right there, which we'll get into. Okay, but right now, when we talk about end behaviors, what I really am referring to is what happens out here. Okay? After it stops doing its little ups and downs and roller coaster looking stuff, what is this function doing? Is it going up or is it going down on each end? Okay? Same thing over here. That's all. Now we're going to find a mathematical way of describing this, and it's important you can understand the terminology that's used and the symbols. But really all we're asking is for us to just kind of ignore this stuff right here and just look at the outside edges and see what's happening. Now, as I erase this, you need to know there's some very easy ways of seeing this. It's not something you have to calculate. All it is something you have to identify, some patterns you have to look for. Okay, so we're going to get into those basics right now. Now, if I have a function that says x to the third plus 2x squared minus 5x minus 12. Now, that's not something you should just look at. By the way, we'll say that's a function, so equals f of x or equals y, whatever you want. Okay, what we want to know is what's it doing at the very extremes. And basically, when we're looking for that, this is going to be a little inaccurate, but I can just kind of ignore those. Those have an effect on what it does in the middle, where its ups and downs are. But the only thing that really has an effect way out at this end and way out at this end on a graph is the first term. So all we got to do is zero in on what that highest exponent is. Okay. Now if it's an odd exponent, like we have right there, okay, that tells us our graph is going to be going in different directions. Okay, so I'm going to erase these arrows here and show you what I mean. Any odd exponent, whether it's 3, 5, 7, it doesn't matter. It's going to be kind of like a line, which would be an exponent of 1. I'm going to have the function at the right is going to be increasing and going up. Then there might be some stuff happening in between, and we don't really care about all that. At the left, it's going to be going down. So an odd exponent means it's going to look like that. Okay, and I'm drawing arrows all over the place here, but this is the key. It's going down to the left and up to the right, and it may have all kinds of stuff in between, and we're not too worried about that at this moment. Now, what if it's even? Okay, let's take a look at that. If that number is even, so for example, if I have, let's say x to the fourth is my first term. X to the fourth plus something, and we don't really worry about the rest of that stuff. Okay, if that's my function, then this even exponent, that tells me that my arrows are going the same direction. Okay, it tells me that I'm going to be going the same direction. So I'm going to be going up or I'm going to be going down, but they both have to be going the same. So it might be kind of like this. There might be some ups and downs in the middle. I'm not too worried about that, but both arrows are either going up or both arrows are going down. So to reiterate, odd means arrows are going opposite directions. So one's going up, one's going down at the opposite ends. Okay, now which way is which? We'll get into that. Even means they're both going up or they're both going down. So that's our first distinction to make. Now, the only other thing we need to change is this. We are going to basically, let me erase this right here. Okay. And we're going to look at, in fact, I'm going to erase this entire function because I just want you to see the first term, not the rest of that stuff. So if our first term was, let's say, x to the fifth, okay, that's odd, and it's also positive. So that means it's going to be going opposite directions because of the odd exponent, and it kind of has a positive slope to it. This is sort of a positive slope, like a positive line. Okay? Because this is a positive number right there, whatever the leading coefficient is. Now what if I were to have negative something x to the fifth? How would that change this? Well, they'd still be going opposite directions, but now it's going to be kind of a negative slope, like a line. Let's go back to our evens. If we had positive x to the fourth, okay, so positive something, doesn't matter how big that number is, positive something x to the fourth, we're going to have ends that are pointing the same direction no matter what happens in between, but they're going to be pointing in the positive direction. They're going to be going up. If we have negative x to the fourth, okay, or any even exponent, but it's negative, then they're both going to be pointing down. And those are really only the four things we have to memorize, those four scenarios. Doesn't matter what those numbers are, as long as they're odd or even, positive in front or negative in front, we can tell what this graph's going to do at the very edges.